Okay, so we recorded the class. Okay, so please behave. Don't make noise. We recorded the class, which we can put in the Waidsum Academy YouTube page for later use. We can even send it back to you to use again. Okay. Okay. Now let's. Today's chapter is 7, which is molecules and compounds. Science grade 8, molecules and compound. So at the end of this chapter, these are the things we expect you to have an idea about. We want you to understand how atoms combine. You remember chapter 6 we studied the atoms and elements. So here we want you to understand how atoms they combine together to form molecules. We want you also to be able to explain the difference between the elements, the mixture, and the compound. So you should know the difference between an element, a mixture, and a compound. You should be able to differentiate between them. Then again, we want you to be able to identify and name some common compounds, some very, very basic common compounds. Again, we want you to read and understand the chemical formulas used to name compounds. The formula, like for example, water, we say H2O. So you need to know the chemical formula that are used to name compound. Okay, we say chlorine Cl2. So you need to know the chemical formula for elements and for compounds. Then again, you need to be able at the end of this chapter to be able to describe different chemical changes. Be able to describe them, the chemical changes that occur. And then we also want you to be able to investigate the method that is used to identify compounds. Which method do we use in identifying compounds? So we start with molecule. What's a molecule? You know that atoms they join together, right? They can join together. Joining together means bonding. When we say joining together, we're saying that they bonded together. You know, atoms can bond in IGC, for IGCSE level. You're going to learn about bonding, chemical bonding. You learn about the covalent bonding, ionic bonding, metallic bonding, and so on, hydrogen bonding, and so on and so forth. Okay, but bonding is like when atoms chemically combine together. When two or more atoms chemically combine together, that's what we mean by bonding. When they chemically combine together, and they do this in different ways. They can do it by transfer of electrons, like the one we call ionic, like in the between metals and non-metals. You know, the metals they transfer their utmost electron to the non-metals, and then that becomes an ionic bond. And or they do it by sharing, they don't transfer. This one say, no, I will not give you my electrons. You have two electrons and I have two in the atmosphere shell. You have two in your atmosphere, let's share. It's just like cooperation. Okay, you bring I bring rice, you bring beans, we cook rice and beans, then we share. Okay, I don't want to eat rice and you don't want to eat beans. You want to eat rice and I want to eat beans, so we combine, we can cook and share. So this type of phenomenon is very relative to the sharing way, the covalent way. In covalent bonding, the covalent bonding happens between two non-metals, okay. So it happens between two non-metals and they share, they just share whatever electrons they have in the outmost shell, okay. So we say when two or more atoms bond together, they will form a new particle. For example, let's talk about this. When two or more atoms they bond together chemically, they will form a new particle. Now, this particle is called a compound. This new thing that they form is called either a compound or a molecule. It's called a molecule so simply, okay, because if a compound is a molecule. So when the two or more atoms form together, they form a molecule. They form a new particle called a molecule. So molecule is when two or more atoms chemically combine together. So a molecule is when it's defined as two or more atoms that are chemically combined together. Two or more atoms that are chemically combined together. Is that okay?
Yes.
Okay, now let's take a look at that from here. For example, let's use the whiteboard to do one or two illustration. For example,
Okay.
let's start with the simplest one. Let's start with the simplest one. Let me start with water. Take a look at this one. We have water. Water is made up of, see, this is the structure, what it looks like, the chemical composition. You have an atom of hydrogen, another atom of hydrogen, two atoms of hydrogen. Let's assume this white one is hydrogen, and this one is also hydrogen, and this is oxygen. So you have two atoms of hydrogen with one atom of oxygen. That's what makes water. Let's take a look at it. For example, water, let's go to the board. Water, let's say our pen, let's write. Water, okay, let's clean this one off. Water equal to, we can increase the font size. Oh, okay, enough. Say water, no, I don't want test. Water equal to H2O. H. You know, these two cannot be subscript. I don't want text. Text is Yugo Shoko. Let's use the writing one. I think I prefer that. So let's get rid of this. Okay, let's use the writing one. Water, water is equal to H2O. This there, H2O. Water is equal to H2O. Is that okay? Is this okay?
Okay.
Meaning there are two atoms of, let's say we have a bond here. Let's change the color. Can we change the color? Let's say we have one atom of hydrogen, another atom of hydrogen. You know there are two hydrogen here, right? There are two atoms of
Yeah.
hydrogen. Okay. There are two atoms of hydrogen. Let's use a different color for this one. And then we have one big one for oxygen. Okay? So this is water. Then it bonds here. And it bonds here. This is structure, right, of water molecule. This one is hydrogen, one atom of hydrogen, and this is another atom of hydrogen.
And one oxygen.
And one oxygen. This is the oxygen. So this whole thing is called a molecule. It's one molecule. This one is what? One molecule of water.
One molecule.
One molecule. Because there's one at the back here. You know, we don't write it. You know, there's one here, right? Which we don't write.
Yeah.
Yeah. So it's called, let me look for eraser to remove that one. There's one here which we don't write. Which we don't write. So there's one molecule of air. One molecule of air, water. One molecule of water. So if it's two molecules of water, how will I write it?
H2H2.
This is equals to 1m. For molecule, let me use m so that we'll not waste time. So we say 1m. Okay, if it's two molecule, I'll write like this, right? H2O. Then I'll put 2 at the back, right? I'll put 2 here at the back.
Yes.
So this will be equal to what? 2 molecules of water. This will be 2m, 2 molecules. Are you with me?
2 molecules of water.
Yes,
Yeah.
2 molecules of water. If I have 5 molecules of water, I have what? I have H2O, H2O, right?
5.
Then I put 5 at the back, right? So this is 5 molecules of water.
Yeah.
This is equal to 5 molecules. Do we understand now?
Yep.
5 molecules. But however, here we only have two atoms. Let's talk about the atoms now. We have two atoms of hydrogen and one atom of oxygen, right? For this one molecule of
Yes.
water. For this one molecule of water, we have two atoms of hydrogen and one atom of oxygen, right? Right?
Yeah.
Okay. But
Yeah.
for these two molecules of water, hmm, the atoms of hydrogen is now what? What is the number of atoms? 4. Do you know why?
As there is two molecules of
Because 2 times 2.
Yes, good.
Yeah, the 2
Because
in the front and the 2 behind the hydrogen.
okay, good. These two behind the hydrogen is going to be multiplied with the two atoms of hydrogen. So this two is talking to everything. So it will
Yes.
now be hydrogen will be for atoms. The hydrogen will be equal to 2 times 2. 2 multiplied by 2, which is equal to 4 atoms. For this case, 4 atoms. 4 atoms. Okay, for this one. To be 4 atoms. Is that okay? How many atoms of
Yes.
4 atoms of hydrogen? 4 atoms of hydrogen. How many atoms of oxygen?
Hydrogen.
Yeah. How many atoms of oxygen do we have here?
two.
2. Oxygen will be 2 because it's 2 times 1. Oxygen number of atoms will be 2 because it's 2 multiplied by 1.
Times 1.
Here means 1. There's 1 here, even if we don't write it in science. Normally we don't write 1 when we write it with variables. Okay, so you say 2 times 1, which is equal to 2. 2 atoms of oxygen. 2 atoms of oxygen. Let me write big O. This one of O2. 2 atoms of oxygen. This one of hydrogen. Hydrogen is diatomic, so it's H2, right? Okay, so 4 atoms of hydrogen. Okay, so that's it. Here, how many atoms of hydrogen do we have? 10. Thank you. A number of atoms of hydrogen here is 10. 5 times 2 is 10. And the number of atoms of oxygen we have here, 5 times 1, 5. Okay, so we get the concept, right? Do you want another example, or we should go to another compound? Use another compound. Yeah, now we take another compound.
Another compound. I understand.
Okay, good. Now let's take a look at this one, this second one, oxygen. Oxygen is diatomic. So it's diatomic. So let's draw it. Let's draw the structure. Okay? Let's draw the structure. Okay, now we move that one down. Let's do for another one now. I want to do for oxygen. Look at the oxygen from what we have here. See? It's bonding from both ways, right? Oxygen to oxygen bond is double bond, not single bond, double bond. One here, one here.
That's why it's O2.
Yes, that's why it's O2. Okay, that's why oxygen is O2. So it's a double bond. Oxygen to oxygen, like this, is double bond. It's not a single bond. It's like this. It's like this. It's like this. That's why you write it like this. That's why you write it like this. O2. It's double bond. Okay. So now take a look at diagrammatically. Let's say like this. If you draw it as a diagram, you draw another one here as a diagram. Okay. Let's take another line to illustrate this. So here it's bonded this way like this, and also from this way it's bonded like this. Okay, so this is the bonding. This oxygen. This is oxygen, and this is oxygen. Okay, so this is equal to one molecule because it's two atoms of oxygen bonded together. So equal to one molecule. Are you with me? This equals to one molecule. This equals to one molecule. There's two atoms of oxygen, right? Two atoms of oxygen. But if we have like this, if I have 6 here, how many molecules do we have now?
12.
Molecule. How many molecules?
6.
6 molecules. This is 6 molecules of oxygen. 6 molecules of oxygen. How many atoms of oxygen?
12.
12. This equals to 12 atoms. 12 atoms
Oxygen.
of oxygen. Okay. This is equal to 12 atoms of oxygen. Is that okay? Do we understand?
Yeah.
Okay. Now let's go to the next one. Let's say the next one. Let's take carbon dioxide. See carbon dioxide. Carbon dioxide we have CO2. That's the formula, CO2. Right? So let's write that, then we draw the structure. Let's write that CO2 and then we draw the structure. Let's go to the board here. Okay, now let's take a look at CO2. CO2. This is carbon dioxide, right? This is one molecule of carbon dioxide, one molecule. Now the bonding is carbon is in the middle here. Double bond this way to one O, one oxygen, one atom of oxygen. Also double bond this way to another atom of oxygen. Okay, if you draw it diagrammatically, this is CO2, this is the bonding, covalent bonding, this is the covalent bonding, double bond this way, double bond this way. So if you draw it, we can have the carbon in the middle here. If we draw the diagram, this is the carbon. Okay, is going to have a double bond to one atom of oxygen here, also another double bond this way to another atom of oxygen. So oxygen, let's use the red. So it's having a double bond to this way and another double bond to this way. Okay, so this is the bonding. This is oxygen, this is oxygen, and this is carbon. This is carbon. Okay, so this is the bonding. Double bond this way, double bond this way. Do you get that? And this is one molecule of carbon. If we write, this is equal to one molecule. One molecule of carbon dioxide, of CO2. Now, if we have 2 CO2, how many molecules of carbon dioxide? 2 molecules. How many atoms of carbon? 2. How many atoms of oxygen? 4. Okay, if I write 10 CO2, how many molecules of carbon dioxide? 10. How many atoms of carbon? 10. How many atoms of oxygen? 20. 10 times 2, 20. Is that okay? Do we understand now?
Yeah.
Okay, so we can move on. This one is nitrogen. Okay, before I move on, let's illustrate nitrogen a little bit. Okay. Let's illustrate nitrogen. Oh, okay, let's illustrate that of nitrogen a little bit. Nitrogen is N triple bond. Okay, let's take the bond with a different color. 1, 2, 3 is a triple bond to another N. So is equal to your N. Sorry. To another N, which is equal to your N2. But the bond is triple. You know, we have single bond, like in the case of chlorine. Oxygen is not single bond. Cl2, this is a single bond, which is equal to this one, Cl, single bond to Cl. You know what result to the number of bond? You know, for chlorine, they're looking for one electron. The atomic is chlorine is 287. If you do the electronic configuration, 287. So the first shell we have 2 electrons. The second shell has 8 electrons. The third shell should have 8. It's looking for 1. So since it's looking for 1 electron to complete 8, since it's looking for 1 electron to complete 8, are you with me? So it will have only single bonding. You know, the atomic number is 17. Chlorine, the atomic number is 17. Don't worry, you're going to do this one in higher level. Atomic number is 17, which is the number of protons. So if you break it down, first shell should take 2, second shell must take 8, third shell must take, it's supposed to be 8, but the only thing remaining is 7, because 2 plus 8 is 10 plus 7 is 17. So the number is 17. So it's looking for 1 electron, so it will only do what you call single bonding. But oxygen, in the case of oxygen atomic number is what? 8. Atomic number is 8. So if you do the electronic configuration, electronic configuration, EC, the first shell will take the maximum number of 2 electrons. Second shell only left with 6 after you take 2. So it's looking for 2 more. This one is looking for 2 more electrons. So it's going to have double bond. Anyone that is looking for 2 electrons to complete its outer shell will do what we call double bond. If you are looking for 1 electron to complete 8, you have what we call single bond. But nitrogen, why does it have a triple bond? Nitrogen has a triple bond because the atomic number, what's the atomic number of nitrogen? 7, right? Atomic number is 7. Yes, the arrangement in the periodic table is in position 7. In the arrangement in the periodic table is in the position 7. Are you with me? So in the arrangement in the periodic table is in position 7. Are you with me? Yeah.
Yes.
Is in position 7. Since it's in position 7, then it means that if you draw the electronic configuration for nitrogen electronic, first shell, I know you'll be wondering what is this electronic configuration. First shell will take 2, the second shell only has 5 left. If it has 5 left, meaning it's looking for 3 more. It's looking for 3 more, right? To complete 8. It's looking for 3 more. This one was looking for 2 more to complete what? To complete 8. That's why it's double bond. This one is looking for 3, so it will be triple bond. So nitrogen to nitrogen, we undergo what we call triple bond. The number of electrons you are looking for in order to complete 8 determines the bonding you will have. Is that okay? If you are looking for 1 electron, you have a single bond, like the case of chlorine. Chlorine is looking for 1 electron to complete 8 because the last shell has 7. The last shell has 7. So it's looking for 1 to complete 8. You just need to find 1 electron from a metal like sodium. Sodium has one electron that can give to chlorine. That's why they can form sodium chloride. So when they bond, they can form what? Sodium chloride. It can form sodium chloride. Sodium has one electron to give to chlorine that is looking for one. Then they form ionic bond sodium chloride, the common salt, the salt we use. If you're looking for two electrons, like in the case of oxygen, if you're looking for two electrons, you have double bond because you're looking for two electrons to complete your 8 in the atmosphere. If you're looking for three electrons, in the case of nitrogen, you have a triple bond because you're looking for three electrons. Are you with me?
Yes.
Okay, how do we do this? Let me do a simple bonding this thing for you. This is a nucleus. You know, you've studied this in chapter 6. The nucleus contains the protons and the neutron. The nucleus of an atom contains the protons, the number of protons and the number of neutrons. The electrons are in orbit. Okay, let's just draw it like circular arrangement. The first shell has two electrons. The first shell has two electrons here. The first shell. This is the first shell that is orbiting the nucleus. Has two electrons. Now let's take, which atom are we doing? Let's say sodium. Or let's say chlorine. Let's say chlorine that has a single bond. Chlorine. Right? Let's say for chlorine. The second shell, chlorine atomic number is what? Atomic number is the number of protons. If you look up the periodic, if you don't know, you look at the periodic table. Okay? You need to know the first 20 elements and the electronic configuration. And that means electronic configuration means how we arrange them in shell. The first shell will be 2, the second shell will be 8, the third shell will be 7. So it's looking for every other, apart from the first one, every other one is supposed to be 8, so that it will be stable. So, but the third shell does it have up to 8? It's looking for 1.
Why it's always only
8 makes it stable. Yeah, when you have 8, then you're stable. So this one has 1, 2, the second shell is 8, right? 3, 4, 5, 6, 7, 8. The third shell has 7. Say 1, 2, 3, 4, 5, 6, there's 7. So it's not complete 8. This is the nucleus. This is how it looks like. If we use just circle to represent it, okay? But sodium, this is for chlorine. This is chlorine. This is for chlorine. But for sodium is different. Okay, but we digress a little bit from your textbook. For sodium is different. Sodium, you know, the symbol is Na. Is derived from the Latin name latron. It's taken from the Latin name latron. Can you hear me?
Yes.
Okay. It's obtained from the Latin name latron. So sodium atomic number is what? Or the number of proton? It's 11. The atomic number is 11. So the EC will be what? Electronic configuration or the arrangement of electrons in the orbit is the first shell will always be 2, right? Maximum of 2. The second one will be 8 if the electrons are up to 8. And then the third one will be 1, only 1, because 2 plus 8 is 10, then plus 1 is 11. So if you do that of sodium, you agree that if this is the nucleus, where you have protons and you have neutrons, where you have protons and the neutrons, then you agree that the first shell, let's use a different cross. Let's use cross now to represent this. First shell is always 2. Second shell is 8. Second shell has maximum of 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. The third shell has how many electrons now?
One.
1. The third shell has only 1 electron. Okay, don't mind my diagram. Okay, sometimes they quack. Okay, but just listen to the explanation. Okay, so the third shell has 1. You see, sodium. This is sodium Na. This is the electronic configuration of sodium Na. Now this sodium atom. Now this sodium doesn't need this one. It's not stable. It has to donate because chlorine is looking for 1. Remember this. So it is going to donate. It's going to donate this one to chlorine. It's going to give to chlorine so that he will have. He's going to donate this one to chlorine here. He's going to give it to chlorine. So it's like donate, give. You know, this is a metal. So there's a metal. Metal, I call them. This is a metal. Metal, they are like men. Non-metal, they are like women. They don't get offended, okay? It's just the way life is. The metal they give.
Okay.
Most times the men they give, right? They have to do. It's their duty. They have to work for your school fees. They have to rent a house. They have to buy the car for the family. Most times. Okay, but we know.
Mostly, yeah.
Yeah, mostly. So metals. If we use that analogy, again, metal they donate, they give. So this electron, it doesn't need it. It's making it unstable. So it has to give it to chlorine, that is a non-metal. This is a non-metal.
There
The-
are different elements.
yeah, this is a non-metal. Okay, this non-metal chlorine is looking for 1 electron, and the sodium, metal sodium, has 1 electron in the atmosphere. Atmosphere means the shell that is that is in the outer part of the nucleus. Okay, the shell that is to the outside world, the atmosphere. So it has only 1 here. So that one he will give it to chlorine, so that chlorine will be 288. 288. This one will now be 288. If it receives, chlorine will now be chlorine ion. It will now be, this will be 288. 288. Why it becomes ion? Because it has gained electron. If you lose or gain electron, you become an ion. We're going to talk about that. When you lose electron, you become an ion, or when you gain electron, you become an ion. Sodium will now be what? Sodium ion. Sodium ion. Sodium ion.
I'll take it.
Sodium ion will now be what? When you are positive means you lost 1 electron. When you are negative means you gain 1 electron. I will also explain that. This will now be 2,8. No more 2,8,1. This is now 2,8. It has lost that 1 electron. This 1 electron he has donated it. Sodium ion has donated it to. Sodium ion has donated this 1 electron to chlorine. Chlorine, instead of 287, is now 288. Sodium has lost 1 electron. You know, when you lose electron, you know the number of proton is equal to number of electron in an atom. And that's why an atom is said to be electrically neutral. And for sodium is 11. So if you lose 1 electron, you now have more proton. Proton will be 11. You know, proton make an atom to be positive. Proton will be 11 because proton is positively charged. Electron is negatively charged. Your electron, if you lose 1 electron, your electron will now be 10. So that atom, sodium atom, is now more positive than being negative. That's why we write this plus on top. I'm explaining why we have this plus on top. The ion, on top of the ion, why this sodium ion, why is it positive? Because it has lost 1 electron. Okay, the number of electrons now they are 10. They're no longer 11. So but proton, the number of proton is still 11. So it has more positive than negative. Since you know this one is for positive. Proton is for positive. Let me use the black pen. Proton is equal to positive. This is for positive. Electron is for negative. So it's now it now has more. It now has more positive than negative, because positive is 11, negative is 10. For that singular reason, we say sodium is now positive because it has more positive. It has more positive ions. So we write sodium plus. But if you gain electron, like in the case of chlorine, why is chlorine negative? Why is chlorine negative? Why is chlorine negative? Because it has gained one electron. It didn't lost. This one, this one will lose this. This one will come here. Okay, it will gain one electron. When chlorine gains one electron, you now see chlorine. The proton is 17. This is for chlorine, right? If we do for chlorine, the proton is 17. Proton is 17. Because it has gained one electron, electron will be what now? 18. Electron will be what? 18. So it's now more negative, right? It's now more negative. So once you are more negative, we now put minus on top. So when you gain, you become negative. When you lost, you become positive. Okay, let me use scripture to explain this. For example, God said when you give, when you give is like you lost something from yourself, right? You take your money, you give to someone else, right? Let's say 10 ringgit or $10. You take from your money $10, you give to someone. Like you just gave to someone who doesn't have. But it looks like you lost. It's like you lose something, but you didn't. You become spiritually more positive. You become positive. You become happy. You become positive. So when you lose something spiritually, you become positive. Like because sodium lost electron, become positive. And when you receive it's like a bit negative, you're down, you feel bad. You'll be feeling bad about yourself that you a beggar or something. So that's just from the spiritual angle. But the real chemistry reason is what I've explained. Is that okay? Now let's move on to the normal class. So let's move on from here. We've seen this concept. You don't have to go through this. You go Shoko. I've explained all this concept, describing molecule using formula. I've also used formula. Now, how have I used formula? How have we used formula to explain this? We've done this already. We say we've used formula to write water, H2O. We use formula for most of the things, CO2 for carbon dioxide, right? We've said water. Let's begin to write. You measure any compound you know, let's write the formula. Okay. Hello, can you hear?
Back around the toilet.
Okay, can you see? Can you see the board?
Yeah, I can see.
Okay. Water is H2O, right? Then carbon dioxide, carbon dioxide, carbon dioxide is what? Carbon dioxide is CO2, right? Measure any other compound. Let's write the formula.
Glucose,
Glucose,
C6H12O6.
good. Glucose is C6H12O6.
Sodium
Sodium
chloride,
chloride,
Sulfur dioxide,
sulfur dioxide. Sodium chloride. Let's finish writing this one first. Sodium chloride.
carbon monoxide,
Yeah, anyone you measure, tell me the formula. Sodium chloride is NaCl, right? Anyone you measure, you must tell me this formula. Sulfur dioxide is CO. Sulfur dioxide. Carbon monoxide is just CO. Sulfur dioxide is SO2. Sulfur trioxide is SO3. Okay. So mention anything. Hydrochloric acid is HCl. Hydrochloric or hydrogen chloride. Hydrochloric.
Now you can make a table, right?
Yeah, this is more or less like a table. Hydrochloric, more or less. You know the meaning of that, right? Hydrochloric acid. Hydrochloric acid is HCl, right? And so on and so forth. So this is it. Now let's move on quickly. Methane is CH4. Ammonia, okay, let's write those ones. They're super significantly important. Let's write ammonia.
I know it's text this
Hmm? Ammonia. Ammonia is NH3. NH3. Okay? Methane. Methane is an organic compound. Methane, got it from petroleum, is hydrocarbon, is CH4. Methane is CH4. So we should know the formula of a compound. This is one molecule. All of them we've written, they are just one molecule. So if you want the more molecule, you put two behind it. You put two behind it. Is that okay? Okay, so let's move on. Let's move on. Here are some questions. It says list the elements found in each of these molecules, right? How many atoms of each of the elements will be? Okay, so which elements are here? Can you tell?
Carbon and
What's this?
hydrogen.
Yeah, carbon and hydrogen. How many atoms of carbon? Two. How many atoms of hydrogen? 4. Okay, all of this one, we have nitrogen and oxygen. 2 nitrogen, 2 atoms of nitrogen and 4 atoms of oxygen. Here is carbon, hydrogen and oxygen. This is glucose. 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. So which of these molecules contains atoms of one element only? One element, fluorine, this one. These are 2 atoms, but it's one element, fluorine and chlorine. One element only. Draw sketches to show the difference between a molecule of carbon monoxide and a molecule of carbon dioxide. Okay, carbon monoxide is just C2O double bond. This one is C2O double bond one side, C2O double bond the other side, like we've done before. Okay, so these are some questions for you. Now, what are compounds? Let's quickly go through. Everything we've studied, they are called compounds. Everything, the water, the molecule, the methane, the hydrochloric acid, a group of elements that are chemically combined together. The combination of 2 or more elements. All of this, except these 2, except chlorine and fluorine, they are not compound. Because they are made up of atoms of, they are called elements. These are called elements. This B, chlorine, is called element and fluorine is element. Because they are made up of atom of only one type of element. They are made up of only one type of element, atoms of same element. Now this one is made up of atoms of different elements. Anyone that is made up of atoms of different elements, they are called what? Compound. This is a compound. Hydrogen sulfide. Okay, this is a compound, hydrogen sulfide. This is a compound, trioxosulfates. This is a sulfur and oxygen, and so on and so forth. So compound is a mixture of 2 or more elements that are chemically combined together. So there must be chemical reaction in order for compounds to be formed. Because you take hydrogen, you take oxygen, you react them together chemically in order to produce a compound. Is that okay? Now, how do we name compound? So if a compound ends with halides, now let's see what we call halides. If a compound ends with halides, halides, halides are the halogen. Have you heard of the halogen in the periodic table? Group 7 of the periodic table. You can check group 7 of the periodic halogen. Group 7 of the periodic table, they are called the halogen. They start with fluorine, but we don't normally consider fluorine because it's too explosive, it's too reactive. So normally we consider bromine. We consider chlorine, bromine, iodine. Acetate is part of it, but it's more or less not very reactive.
I don't see him right. That would be
Eh? Look at group 7. They are called the halogens.
This is
Fluorine,
right?
yes. Group 7. See group 7. Fluorine, chlorine, bromine, iodine, astatine. See? But we are not considering the first and last so much. 80. This is 80, okay? Small substrate T. We are not considering this one because it's too reactive. We are not considering this because it's very slow in reaction. So we consider basically these ones. We consider basically these ones. So this one, the chlorine, the bromine. So when a compound contains a metal and this, you don't call it sodium chlorine. You don't pronounce the compound sodium. Let's say you have this one, NaCl.
They block them out, making one iron. Locally, they don't receive one iron. Not that students said they are not wearing uniform.
Okay, let's say here is sodium chloride. Let's say here is sodium chloride. So it's you call it sodium. You don't say sodium chloride. Anyone that ends with halides, anyone that ends with halide, you measure the metal first. Okay, when they give you a metal and sodium and chlorine, a halide, you say sodium chloride. You pronounce it as chloride, not chlorine. It ends with IDE. It ends with IDE. It ends with IDE. Okay, it ends with IDE.
For singular.
Yeah, any of the halide. If it's bromine, you say bromide, sodium bromide, or potassium bromide. So you must end it with IDE.
And if it's plural.
If it's iodine, you say not singular. We're not talking about singular. Any reaction that you take a metal like potassium and bromine, if they ask you to name it, they say name it. You say potassium bromide. You end the bromine instead of say potassium bromine. You pronounce it as you end it with IDE. If it's any of this halide, if it's chlorine, you say potassium chloride. Potassium chloride. You don't say potassium chlorine. Is that okay? You don't say potassium chlorine. If it's iodine, you say potassium iodide. Potassium iodide. You don't say potassium iodine. You say potassium iodide. Iodide. You don't say potassium iodine. It must end with IDE. It must end with what? IDE. But you must measure the metal first. You see, we're always mentioning the metal. Sodium, bromide, sodium, calcium, bromide, calcium chloride. You measure the metal first. After you measure the metal, then you follow with the halide. And the halide, you will not say chlorine. You say chloride. You end with the chlorine with IDE. Chloride, bromide, iodide. You end with IDE. That's one way of naming them. Okay, quickly. So here is pure substances. Pure substances are those substances that have only one type of atoms. If it's fluorine, it's only fluorine atom. If it's chlorine, it's only chlorine atoms. It's not mixed with any other atoms. Is that okay? Pure substances could be in element form. Could be in element form, also could be in compound form. But there are no impurities that are mixed with it. Is that okay? I think this is where we stop for today. Yeah, this is where we stop for today. So you answer these questions. Okay? So this brings us to the end of our class today. Thank you.